Hi everyone. Good evening. Good morning. We will start in a couple of minutes. So please stay tuned. So yeah, let's get started. I have shared my screen. So can you please give me a thumbs up if you are able to see the screen and hear me properly? Anybody? Thank you. Thank you. Okay. So let's get started. And I will give you a recap of what we have done in the last class till now. So in the last class, we have seen various features of Azure Cloud in terms of the virtual networking. We have seen how do you plan for a virtual network, how do you create subnets, how do you create a virtual address space, how do you make sure that you select the right IP address range, and so on in the last class. And before that, we have seen the storage services in which we have seen how to create a storage account, a blob storage container, and also a file share. And this is like before that, we have also completed our Azure compute services in which we have created virtual machines, VM scale set, and so on. Now, today we are going to move ahead and we are going to start with another very important concept in any cloud service provider, and that is the load balancer. Now, what is load balancer? So we will see it and how do we apply it for our environment. We will see that as well. So, so Azure load balancer or a load balancer in general, it's a device. Okay, let me take a paint and let me show you something. So this is a device. Okay, if you are able to see this, this is a device. I call this as a load balancer. And behind this load balancer, we have multiple servers, web application or web servers. So I call it server 1, server 2, and server 3. Now, all these three servers are hosting a same kind of application, which is your, let's say this is your e-commerce website, e-com. Yeah, you know, all of them are hosting a e-commerce website. And this kind of architecture, when we are having multiple servers serving the same content, is kind of a distributed architecture. Now, what happens is whenever somebody wants to reach to this server, this is front-ended by a device which is called as load balancer. As the name suggests, it is going to balance out the amount of traffic which is coming into your application. Your application might be hosted on some website, for example, Excel, ExcelR, ecom.com. Yeah. Okay. So this is your website URL, and all of your users might be trying to reach to this URL. It is. And once somebody tries to hit this, it comes to this device which is called as load balancer. Now, this load balancer, what it does it sends the traffic to your pool of server which are sitting behind your load balancer. What it does it sends the traffic somewhere here. I will use another color. So from here, it goes here, it can go here, it can go here, it can go here, and so on. Now, how this is done? This is done by a device which is called as load balancer, and generally it is kind of a round robin. Okay, generally I'm saying, but yes. So once it goes here, then here, and then here. So actually, what is happening is your traffic is distributed among a pool of servers, and that is the functionality of your load balancer. It is a single point of entry for your application traffic, and this application traffic will be then passed on to your pool of machines which are sitting behind your load balancer. So this is the general concept. I hope you understood this concept. So coming back to the load balancer of Azure, here it is. So now, whenever you want to use a load balancer in Azure terms, there are different varieties of load balancer. We have a basic load balancer, we have an application gateway, and then so on. So before we go into this, I want to share a link which is going to give you an overview of a load balancer. Here is the link, and very basic. Okay, and here is the URL for it. It gives you more details as to what is the load balancer is and so on. Okay, sorry for that. Yeah. So here is a page, okay, and which gives you a very clear understanding of how load balancer will look like. Based upon the type of load balancer, you will have your traffic distributed based upon different layer of your OSI model. I hope you are able to understand what is OSI model, which is Open System Interconnect, wherein you can, yeah, you can uh, put your all the environment into different layers of this OSI. And one of the layer is layer 4, which is your transport layer, or you can also call it as a network layer, which is actually third layer, which is network, but 4 is the transport. And it is going to work at that layer. Now, the load balancer which we are talking right now is we are talking about a layer 4 load balancer. You can see here is the traffic which is coming onto your load balancer, and that is being distributed across your servers which are sitting behind your load balancer. Coming back to our, yes. So whenever you do that, there are two ways you can route the traffic. One is from a public facing load balancer, which is this one. Yeah. which is the public facing load balancer, and the second one is internal load balancer. When you have a public facing load balancer, it is going to load balance the traffic which is coming from the internet. And when it is an internal load balancer, it is only going to route the traffic which is part of your internal network. Hmm? So when I use a load balancer, I need to have something called as front end IP address, and then I need to have a backend pool. Backend pool is nothing but a pool of machines which are sitting behind your load balancer. Now this load balancing will happen based upon some kind of a load balancing rule which you have to set, and you can also set some kind of a health probe on your load balancer so that you understood or you understand that this machine where I'm sending the traffic is working properly and is able to take the traffic. If it is not working properly, my load balancer will understand based upon the health probe, and it will just simply send the traffic to these two machines rather than the one which is unhealthy. So this is a general basic concept of your load balancer. So this is how you implement a public load balancer. You have traffic coming onto your load balancer. We need to use something called as listener port. Now this port is generally for a web server is port number 80, and your traffic is coming from your internet. This load balancer will sit under your VNet, and this is going to divert the traffic onto the virtual machine on the port 80. So in the both cases, we are using a port number 80. So this is the listener port for your load balancer, and this is for your virtual machine. So what it does, it maps public addresses and port number of incoming traffic to the VM's private address and port number and vice versa. Apply load balancing rule to distribute the traffic across virtual machines or service. So that is what we are going to see it. One more thing. Here is the list of the components which we are going to see as part of our load balancing. Here it is. Yeah, so you can see we have a backend pool. Then this is the front end IP configuration, that the backend pool, then the health probe, and the load balancing rule. So we will see all of them one by one when we are going to configure our load balancer. We will also have a NAT rule for the machines which are part of your private subnet. So we'll see that as well. Okay, but we'll not configure it, but I will just go through it now. So yes, before we go there, let me look at the type of load balancer we have. Um, your sir type. Here it is. Okay, we will go to the, yeah, here it is. Okay, so here is the load balancing option we have. Okay, this is the table which summarizes the load balancing services based upon particular service. Now we are talking about a load balancer which is layer 4. Yeah, and then we will talk about the application gateway which is layer 7, and this is a regional service which works on HTTP, HTTPS, and then we have a traffic manager which is a global service which along with the load balancing also does some more things from the routing perspective, and we'll see that as well. And the last one is the front door. Okay, we'll not look at the front door, but we'll look at the three of them. So I'm going to share this link for all of you so that it is handy for you to go and understand more about it. Here it is. And one more, this is the basic of the load balancer. So we are going to look at a demo, and in the demo, we are going to create a basic load balancer with two machines, or we can also add multiple machines to it, and we will see how the load balancing works. So for the simplicity, I have already created a load balancer, but I will run through what we are going to configure it. As the load balancer is going to take some amount of time to create, so I have already created for you, and we'll see that. So fine. So we are going to create a public load balancer, which will have a public IP address, and that's why we will be able to reach it from the public IP address and use it. Hmm. Then we can also implement an internal load balancer, which will direct traffic to the resources which are part of your virtual network, or anybody who's trying to access that particular resource by using the VPN, or which is part of the complete Azure infrastructure. Hmm. The front end IP address and the networks are never directly exposed to the internet endpoint in this case. Yeah, and it enables load balancing within your virtual network with cross-premise virtual network or any kind of a multi-tier application within your VNet. That is the then whenever we are going to use our load balancer, we need to look at the various features which are provided by your SQs. So there are two types of SQs. One is standard, one is basic. If you see based upon the features, you will get different features for those the SQs. Now, if you go for a basic SQ, you can have a backend pool which can support up to 300 virtual machines. Hmm. And if you go for a standard, it is going to support thousands instance. The health probe which we can use with this uh, basic SQ is TCP and HTTP. It is not secured. Okay, so in this case, here we can use TCP, HTTP, and HTTPS. The concept of availability zone is not available with the basic SQ. You can use only availability set. Remember, we have already seen the availability concept in virtual machines. So this is talking about that. Then we have a zone redundant and a zonal front end for your inbound and outbound traffic with your standard SQ. Yeah, you can have multiple front end for inbound only, but with standard SQ, you can have outbound as well as inbound. It is secure by default, it is open by default, and you can set up NSG as you wish. It is closed to inbound flow unless allowed by NSG. So you need to use the NSG to safeguard it and restrict it. With basic SQ, there is no SLA which is guaranteed by Azure. But with standard SQ, you get a SLA of 99.99%, which means they guarantee that the Azure that standard SQ load balancer will give you a 99.99% uptime. Yeah, or a huge or I would say almost 100% uptime with the SLA guarantee of 99.99%. If this SLA is breached, Azure will pay you some credits to be utilized in your Azure account. So this is how they compensate for any breach in the SLA, and you can very well use it. Okay, so let us go and then create a load balancer. I will just talk through the slides whenever we are going to. So this is how you create load balancer, a load balancing rule, the front end, and all those things. So let us go into the portal. Here is my portal. Yes. So the first and foremost thing you have to do, let me just write down what I'm going to show you. Here it is. So we are going to create a, a first public facing uh, LB. Second, we are going to create two virtual machine as part of a load balancing. Then third, we are going to create a front end public IP, and then we are going to create backend pool and add two VMs to it. And then the fifth one we are going to create, fifth is the health check, and health check, and then the sixth one is load balancing. So in between this step number 2, we have to create a web page on our machine. Yeah. So you have already seen how to create a virtual machine. So in my case, I have created 2 virtual machines. If I go here, there are 2 virtual machines which are already created, and we need to configure a web server on it. Now, remember one thing, your load balancer, when it send the traffic to your backend pool, does not need a public IP address. But because we are not part of the Azure environment, we need the IP address to connect to this machine and configure the web page. And that's the reason I have given a public IP address. Now, as a part of this, I have already configured this, and here it is. Yeah, so I have installed the load balancer, the web page on my this machine. One more important thing is you need to open port number 80, because that is what we are going to use for our load balancing. If I go and use this, the IP address of my this machine, which is my machine number 2, yeah, yeah, yes, I should see a web page, a default web page for it. Yeah, here it is. So let us go and customize it. We have already seen how to customize it. What you have to do is to go to the C drive. I will show it on another machine. Just let us finish this. So I go to my PC, C drive. Then there is a folder which is created called initpub, and then in here we have a www root. And I'm going to edit this file, okay, and put a customized web page into it. So here is my, and I will put a simple HTML code, which will be uh, very simple. Here it is, and I will say this is my LB VM2. This is what I am going to write into it, and I will save it as index.html and with all file. Save it. Because this is my VM number 2. That's the reason I have given this as the content of it. Close it, and if I go onto my web page and try to open it again, I will see this is my LBVM2. Similarly, let us do it for the other virtual machine as well, so that you will be able to see the process from the starting. So I have this machine, I connect to it, connect RDP. I have given port number 80 as well as RDP port for this machine. So that's why I'm able to connect to it. And also the port number 80 is open on it. I connect to it. Here is my more choices, and is your user and the password. Open. Yeah, and here it is. Connecting. Fine. So meanwhile, this is getting done. We will work on our load balancer. So the first thing we have already done. The second thing we have to do in this second thing we have already done, we have to create a load balancer here and give, okay, fine. So this is, yes, we have to create a load balancer for this, and then I will cut this, put it here, and this is actually 5, and this is this is 4 step, and this is 5, and this is 6, and so on. Okay, fine. So load balancer, how do you create a load balancer? So go here and search for a load balancer. You will see a load balancer here. This is the load balancer which I have already created. I will create just one for you just to see it. And here it is. So I can use my this user group. We just create a new user base so that we are able to dupe duplicate lbrg. Okay, and I'm going to give a name, dupe lb demo. Okay, and I'm going to create in the east, and I'm going to use the basic SQ. Yeah, because your standard is costly and I don't want to incur any charges. So that's the reason I'm going to use a basic SQ, and I am going to select it as a public facing. Remember, this is very, very important. If you don't do that, it is going to create an issue for you. Yeah, because after that, once you create the IP address for your front end, then it will be a problem. Next, yeah, I can add a front end IP address from here. Okay, so I can give a name here, dupe lb front end, and then I can choose from the available IP address. I already have one which is already associated with my load balancer. Okay, so I have to, okay, I have to select a new one to use it. But what I'm going to do, I'm just going to cancel it, because once you have it, you will come to this page just to show you. Yeah. You just have to give the IP address and say add, and then you will come to this page. If I go to this, yes, you will come to this page and you will see the front end IP config like this. Huh? And you will have a IP address. So this is how you just create your load balancer. After that, if you go to the next, yeah, I'm not adding here at this moment, but I don't need to go to the backend pool to complete this load balancing. I just say review and create, and it will create a load balancer for me. Now, once this is done, what I have to do, I have to add the next step. And what I have to do, I have to, so I have already created a front end. I have to create a backend pool and add two virtual machines to it. So here, if you can look at here, I have a backend pool. And in the backend pool, this is the name of the backend pool, and you can see two IP addresses. Let me show how it is done. Add and give a name, dupe backend LB, and then you have to select the same VNet. Now, at sometimes you will not see the VNet which is populating here. Don't worry. After you create your load balancer, it takes some time, 2-3 minutes to show it up, and then you will be able to do it. So, and after that, I have to select associate with the virtual machine. And then I have to add the virtual machine. So it will show me the two virtual machines which are part of my environment. I will say add, and I simply say, okay, add it. Okay, now in my case, I have two backend pools. So that's okay. Okay, but I will delete one of them. Okay, this is how you create a backend pool. Let it. So that's why I already created it, because it takes some time. Now this is done. You can see here the backend pool is there. And once your backup backend pool is added, you will see it in the running state. The next thing you have to do is to create a health probe. And this is the health probe I have already created. All you have to do is to select the protocol. In this case, we are going to select the TCP, port number, and the interval for which you are going to probe your machine to get the health status. And in this case, I'm going to do it twice. So number of consecutive probe failure that occurs before a virtual machine is declared unhealthy. So I'm going to try it for 2 consecutive time at an interval of 5 seconds, the amount of time between 2 attempts. And if I get a response, then it is healthy. If I don't get a response, that is unhealthy. So once this is done, I am going to go into my load balancing rule. And here is my rule. Okay, so if I just open it, what I'm going to do is give a name, select the front end IP address, add the backup pool, and then select the protocol port, which is for your this is for your load balancer, and this is for your backend pool, and then associate a health probe, and that's it. Save it. Once you save it, it will be available here. Hmm? So that's it. Your load balancer is completed. Now come to this screen, the overview, and do a see more, and you will see a IP address. Now at this moment, we have added two machines, and one of them has this web page. Let us configure the second one as well, so that we will see the proper web page for it. And I first of all, let me just go to the local server, disable it. Okay, and yes, off. So this is what I'm saying is I'm just disabling the enhanced security configuration, which will prompt you to actually add those webs, whatever the URLs which you are putting in the browser, to a safe list. By doing this, it will not ask you anymore. Let me just refresh it, whether it is done or not. So once this is done, yeah, it is off now. And then I have to install the IIS on it. So I will go to manage, add rules and features, do next, next, next. And on the screen, I will select the web server, which is IIS service, add feature, and then again next, 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 and I will say install. So let it installed now. So I hope everybody is clear till this point. Yeah. Okay. If you have any questions, please put it in the chat, and I will be glad to answer that. So let it happen. Okay. Here is my PPT again. So this is what I have already shown you, how you can do it. Backend pool, give a name, associate with a virtual machine, two SQs to be used, basic and the standard. Okay, a backend address pool contains the IP address of the virtual links that are connected to the load balancer. This is very, very right. And then the load balancing rule. This is what we have already set up. It maps your front-end IP address, a port of your load balancer with the port of your backend pool, and it will map it. You can also have a NAT rule. NAT rule is going to help you for any which is going to give you a connectivity to your private machine to the internet, and based upon that NAT rule, it is going to route the traffic to your that particular set. Okay, so I think our machine must be ready now. Okay, yes, done. So let us take IP address of this machine. This is the first machine, and here is my machine. Take IP address, put it into the browser, which will show me a default web page. Yes, and I'm going to change it, and I'm going to use the same thing. Here it is. Go into the C drive, into the init pub, and then www, and just use this and open with notepad and copy all, delete, put the HTML code, and here it is. See, and this is my what was the name I have given for this? Okay, yeah, this is my, yes. Go here and put it in this. Okay, and this is now VM1. Save as index.html and as a all files, and save it. Okay, let us go here and the web page, not this one. Yeah, here it is. And I will say refresh, and here it is. Now let us go to our load balancer. Let me close this. Yeah, here is my load balancer. Take the IP address, copy it, and paste it in the browser. And it is. And it has gone to the load balancer one. If I refresh it, it should go. Okay, what's happening? This is my backend pool. Both the machines are added. Let me just remove this backend pool. Yeah, let me just remove that. At times it might take some time to get refreshed. Okay, so let me do one thing. Yeah, here it is. Okay, so here it is. The traffic has gone to another server. So this is how the load balancing will work. If I just refresh it, it might go to the first. Okay, at times. Okay, let me do one thing. Copy this, paste in another window. Yeah, it's gone here, and refresh, refresh, refresh. Yes. Okay, after some time, it is going to the other machine. So this is how your load balancing will work, and I hope everybody understood how it is configured. Okay, so that's it for the load balancer, which works at your layer 4. Then we will move to another load balancer, which is called as application gateway. But this application gateway works at layer 7. Hmm? Let us go and look at the link, more detailed link of the application gateway. Here is the overview link for it. Yes, here it is. Overview link. Fine. So this application gateway is very powerful. It has very good features, which are very useful when you want to work with your web servers, and which works at your layer 7. Okay, so it's a web traffic load balancer which will help you to manage traffic to your web application. Traditionally, your load balancer, which we already seen, that operates at layer 7, layer 4, but this load balancer operates at layer 7. It operates at layer 7, and it can do the routing of your traffic based upon the path, the header, and so on. So these are the various features of application load balancer. And remember, it works at layer 7. It supports your SSL and TLS termination. It supports your availability zone. It also supports your static virtual IP address, and it can also be integrated by using it can be integrated with web application firewall or a WAF. WAF is nothing but a kind of a layer 7 firewall which will help you to protect from the open web application security, what you can say, vulnerabilities which are available, and people can exploit that, and this WAF can help you to mitigate those kind of vulnerabilities. Hmm? So that is another topic itself, but yes, you can have a web application firewall which is layer 7 firewall on top of your application gateway load balancer, and it will protect your load balancer. It can also do URL based routing. It, yeah, what is URL based upon the URL. For example, this is the example, contoso.com/video star. It can be routed to one server or pool of servers, and then contoso.com/images can route to another pool of servers. It also helps to do a multi-site hosting. Okay, you can configure routing based upon the host name or domain name for more than one application in the same application gateway. This is very powerful feature. If this has to be done with your basic load balancer, you have to create multiple load balancer to achieve the result. Hmm? So this is a feature of your application gateway. Then it can also do a traffic redirection or it can just simply say, you can say it can do a SSL offloading, for example, from HTTP to HTTPS and so on. So yeah, so if you do a traffic offloading like HTTPS to HTTP, that is called as SSL offloading. Then there is another feature which is available with your application gateway is the session affinity. Now, what is this session affinity? Session affinity is a very, very useful feature which will allow you to send the traffic of your user to the same server which he was using previously when some issue occurred in his connectivity to that server. Okay, suppose he's trying to fill up a form, and then in between the connection got lost. By using this session affinity, what you can do is you can understand the session. Yeah, you can the whatever the session which is there, the user, when he tries to access the same application again, will be diverted to the same session, and he can start using that based upon the cookies which are cached. Okay, so this is also one of the feature of your application gateway. Then yeah, connection draining is one of them. If suppose if by some means your whatever the web server it is not able to handle the traffic, and you are trying to, or maybe it is going into a unhealthy state, then what happens, it will wait for this whatever the connections which are there on that particular server. It will gracefully remove that gracefully remove that backend pool member, and will try to serve all the requests before it gets removed from the pool of the servers. That is also there. Then yes, fine. These are the various features of your application gateway. How it works? This is how it works. Whenever your user tries to send a traffic to the FQDN or the IP address of your application gateway, then it is diverted to the listener port. Then based upon that listener port configuration, you have some rules. Based upon that rules, your traffic can be sent to the virtual machines. It can be sent to another pool which is consist of your virtual machine skill set, or any external HTTP HTTPS server, or even app server. Okay, so this is how it can route the things. Let me just give you this link. Here it is. Yeah, fine. Then yeah, going back to our PPT. Yes. Yeah. So I talked about the path base. Yes, path bases and multi-site routing is also possible with your application gateway. Based upon the path like this and this, you can send that to different pool of servers. And you can also integrate a WAF with this, and then you can also send this to a different, completely different web to domain as well. That is the usage of your application load balancer. The component wise, if you look at the component, it is almost the same what we have seen as compared to your the load balancer, basic load balancer. It has a front end IP address. It is going to have a listener. This is the port on which you are going to listen to the traffic. Then the routing, then the backend pool, and WAF you can add, and then the health probe as well. This is the load balancer. It is the application gateway for you. Now we will move to another very, very important service within the Azure, which is called as Traffic Manager. Now, what does Traffic Manager do? So Traffic Manager is nothing but kind of a service which is going to route your traffic based upon the DNS. Now, what is DNS? DNS is nothing but a domain name system, which helps you to translate a human readable domain name or a name of your website into a IP address. The use of your DNS is to translate that domain name into a IP address. Yeah, at times you also call DNS as a phone book of the internet, which will help you not to memorize the IP address of your web server, but rather than just use the name of your web server. So anything like google.com, yahoo.com, and so on. This traffic manager is nothing but a DNS based traffic load balancer that helps you to distribute traffic to your service across the globe. Hmm? Okay, and this is a very, very highly available and responsive service from Azure. Yeah, traffic manager uses a DNS to direct the request to various clients which are part of that traffic manager, and it is based upon various traffic routing method. With this traffic manager, you also have an option to ascertain the health of your endpoints, whether it is healthy, whether it is not healthy. Based upon that, you can take a decision that yes, traffic has to be sent to the healthy instance only. Hmm? An endpoint is any internet facing service which is hosted inside or outside of your Azure environment. So it can be anything. Hmm? So this is a for you. Then traffic manager can route the traffic based upon different methods. So we will see those method, and which will help you to use your this kind of a traffic routing based upon various scenarios. It can be based upon the location of the user. It can be based upon some kind of a weight attached to the method of sending the traffic. It can also be some kind of a automatic failure. So that is also available. So traffic manager supports 6 kind of a traffic routing methods, and that will determine how you are routing the traffic to that particular endpoint. Okay, so let us go and look at all the different uh, rules. Okay, so here is one of the URL for the overview of traffic manager, and let me paste it here as well. Not here. Yes, here it is. Okay, yeah. So with this page, you can create your traffic manager by using the portal, yeah, or you can use it via CLI and so on. So here is a complete end-to-end walkthrough of what you can do. Now, in this case, you might need a DNS name for this to work, or you can, yeah, you can have, yeah, you need a DNS name for it. So fine. Let us go here. Yeah. Let us look at the various traffic rules, traffic routing rules. So the first and foremost traffic routing rule is called as priority. So priority, when you select a priority, what you do is you send your traffic to the primary service endpoint, okay, at any given point of time. And then once your primary service point is not available, let's say it is down, what happens is you send this traffic to the second or the backup endpoint, which will take care of the traffic. So at any given point of time, you are going to use the primary service endpoint to route the traffic. So this is kind of a active standby or failure backup kind of a scenario where your primary is going to take care of all the traffic. So very simple. Then the second one is called as weighted traffic routing. So when you want to distribute your traffic across a set of endpoints, either evenly or according to the weight of the amount of traffic, you can send the traffic like 80% to server A, 20% to server B. So you can set this weight in your traffic manager, and this traffic manager will help you to route the traffic. So let me just go into the URL for this. Here is one of the modules for it. Yeah, yes, this is, yeah, if I go here, this is about actually application gateway. Let me go to the, yes, here, and routing methods. Routing methods, fine. Here is the routing method. And whenever you do this, you have to set a health check as well. And based upon that, it is going to route the priority traffic. Then weighted, here, you can set a weight as a numerical value. The weight can be from 1 to 1000 integer. Okay, so integer value you can put, and based upon that weight, you will be routed to the right server as compared to your weight. In this case, you can see here the, just a minute. Okay, fine. I cannot take a pen here, but yes. Yeah, from here I can take, yeah. Here's my pen. Um, Okay, so you can see here, you can see the weight is 50. Yeah, and that's the reason the traffic will be routed to this as compared to this. But yes, some amount of traffic might be routed to this as well. Yeah, so whenever after multiple attempts, so after multiple attempts in proportion to the weight you have set on this, traffic will come to the this server as well. Then the performance traffic routing. So let us go here and yeah. So in this case, what you have to do is you have the option, okay, you have the option to place your endpoints in different geographical location. And what it will do, it will send the user to the closest endpoint in terms of the lowest network latency. So what it is doing is it is actually measuring your latency. You means the end user to the server where it is located. So based upon that, it is going to route the traffic to the server or the endpoint which has the lowest latency from the particular endpoints. So here it is. You can see there are three servers, which is one is in US, West US, North Europe, and East Asia. And the user who are trying to reach, let's say somebody is in North Europe, and okay, and he might get a less latency if he's from North Europe, and he will immediately connect to the North Europe. But somebody who's having who's in West US and he has just 15 millisecond of latency, he will be routed to the West US. But again, this can be based upon the health checks. If this endpoint is not available, it will be routed to the next server which has the lowest latency. Look up for the closest endpoint, available endpoint in the latency table, and then it uses the DNS query from the source IP address and try to route it. So this is the performance traffic routing for you. Okay, fine. Then the geographic traffic routing. What happens in this? Okay, so it checks the actual geography of the user where it is located. And based upon that, it is going to route the person who is in that particular location to the nearest server in that location. So it is going to route the traffic based upon the geography of the user. Yeah, direct to the specific endpoint based upon which geographical location the DNS query originates from. This empowers the traffic manager to enable scenarios where knowing a user's geographic region and routing based on them is important. Okay, take an example. Yeah, you have what you can say a website, a website for your immigration, and let's say it's a Canada immigration website, and there are people who are using this from France, let's say from Canada and US. Now, Canada also have a lot of French-speaking public. So anybody who's trying to access that website from, let's say, from France or from even Canada should get a site which is in French. But anybody who's sitting in US should get that website in English. Why? Because maybe less number of people speaks French in US. That's the reason that you want this website to be in the English language. So what you can do based upon this, the geographic traffic routing method, you will divert the people who are coming from US to another endpoint, service endpoint, and people who are coming from France and Canada will be routed to another endpoint. That way they will be able to see two different websites but on the same URL. So this is the use case of a geographic. And then we have a multi-value. Multi-value takes into consideration multiple endpoints, and then it does the routing based upon the queries of all the healthy endpoints which are written as part of the multi-value. Then we also have a subnet traffic routing method, which maps a set of user IP address range to a specific endpoint using your traffic manager. Okay, when a request is received, the endpoint return will be one of the mapped endpoint in that particular IP address range. So this is how the subnet routing works. Again, more details are available in this and so on. Okay, so any question you have in this traffic routing, I am open to take those questions before I can move. Anybody? Any questions on this before we move to the comparison? Yes, no? Huh? No? Okay. Naved, what do you want to understand? Which can you be very specific? Hmm? So it is basically we have just seen how the traffic can be routed based upon certain conditions. Hmm? So this is the use case of your traffic manager. Before that, we have just seen the load balancer which works at different layer of the OSI model. Your load balancer, basic load balancer will work at layer 4. Okay, so let me just explain why this difference, and we will see that. Okay, so how do you, okay, whenever you are using your basic load balancer, it is using the transport layer, which is layer 4. But when you are using your application gateway, it is using a layer 7, which is using HTTP and HTTPS. How it knows the user location? Very good. Suecha, in geographic, yeah, how does it know? So whenever you are trying to access any web URL, okay, your ISP provides you some certain IP address. This range of IP address which is available is mapped to a particular geographical location. And this is coming from your ISP, Internet Service Provider. And that's how it understands that you are located in here. Now, if you have used, or if you know a VPN software, what it does, it emulates the IP address scheme or range from that particular country or a region and assigns that IP address to your machine. And by doing that, it is it is it is assumed that you are in somewhere in that region and you are using your application from there. That's how a lot of people who want to do some malicious act, they use the VPN, the software based VPN, just to what you can say, proxy from another country, but they are sitting in some other countries. That's how. AWS load balancer and Azure load balancer, yes, both are the same. If you look at the comparison, the Azure load balancer is comparable to your classic load balancer, and your application load balance gateway is comparable to your AWS application load balancer. And if you look at traffic manager, some of the functionality of traffic manager are equivalent to the AWS Route 53. Navid, I hope it answers. And Suecha, I hope you got your answer as well. Okay, thank you. Yeah, fine. So the protocol which is supported by basic load balancer is TCP/UDP, but in case of application gateway, it is supported HTTP, HTTPS, and HTTP2, even with a WebSocket. Then the traffic manager, it can work, but it is doing a DNS resolution of your name. In the backend pool, you can have a virtual machine, you can have any public internet, and so on. So in the backend pool, you can have that. You can also have a virtual machine scale set as well. In the backend pool of your application load balancer, you can have any public IP address machine. It can be your Azure VM, it can be VMSS, it can be your web application, web apps, or any Azure cloud service. It can be both internet facing as well as internet. So this supports also this. Now, traffic manager, for traffic manager, the backend pool can be a public DNS, okay, which uses CNAME, and that can include your virtual machines, your any cloud services, your web app services, and any public endpoint. Now, what is CNAME? CNAME is one of the record in a DNS. What it does, it maps your a particular subdomain to another subdomain. Something like this. You have a domain like page, let's say p1.xyz.com, and you want to send the traffic to something like this t1 and .abc.com. Yeah. So if you want to map this, then you have to use a CNAME. This is going to map one subdomain to another subdomain for routing the traffic. You will hit to this domain, but you will actually land on this domain by using this CNAME. So this is how the CNAME works. Then, yeah, health monitoring can be done on the TCP and HTTP. But with your application gateway, it is only supporting your HTTP and HTTPS probe. Here it supports all of them: HTTP, HTTPS, and TCP. Outbound connection, it is supported, and with this application gateway, it is not supported, and even for your traffic manager. Basically, the use of this traffic manager and application load balancer is not intended for any kind of a outbound connection. Then availability zones. Availability zones and zone redundant single IP address for the public and internal front end is supported by a basic. Inbound outbound connection is supported. Cross zone load balancing is also supported. Now, what is this cross zone load balancing? Cross zone load balancing is about sending your traffic to the virtual machine which are situated in multiple availability zones, and that way you are covering for any what you can say problems which can occur with your machine in a particular availability zone. So if your one availability zone is down, still your traffic will go to the another availability zone and your application will work fine. Okay. Then cross zone load balancing is also supported with your application gateway. And then for traffic manager, single DNS record for multiple IP can be done, and cross zone load balancing is also supported. Then protocol support, there's something called as pass through. If you want to go through, just do a Google of pass through. You will be able to understand what is pass through. Then with your application gateway, you will have various other features like TLS offloading, URL based routing, TLS encryption, WAF is supported, and also HTTP redirection is supported. So we have already seen this. Then this your traffic manager, it is platform agnostic. This does not depend upon the platform of the HTTPS protocol for your then sticky session or source IP, it is supported to, yeah, and here it is based upon the cookie. Now, what is this 2 tuple or 3 tuple? It can be based upon the source IP address, destination IP address, and the port. And this sticky session is not supported in your traffic manager. Traffic control is done by your NSGs. Here also your NSGs, and here based upon the geo traffic restrictions. So that's it. The I would say a difference between your LB, which is your load balancer, application gateway, and traffic manager. Fine. Then let's move to the another service, which is called as CDN. Now, what is CDN? CDN is a content delivery network. It's a content delivery network, which is kind of a network of your distributed server, which will help you to deliver the content closer to the user. So how it is done? It is based upon the edge server, which are part of your POP locations, and which will cache the content for the user, so that whenever user try to access that content, it is being delivered from the nearest POP location and providing him the minimum latency. So Azure also provides a CDN, which is called as Azure CDN. It is a global solution for rapidly delivering high bandwidth content to the user closest to their location. It does by caching the content. Take an example. Suppose you are a user who is situated in India, and there is a web server which is situated in US, and there is another user which is situated somewhere in Australia. Now, whenever you want to access this web server which is situated in US, What you have to do, you have to go all the way through the internet and then go to the web server, which is in US. By doing this, your latency and your performance of that particular application will be not as comparable as you want. So what you do is you use a CDN network. The CDN network is what it is going to do. It is going to cache the content whenever you want to access that nearest to your location. So it will cache the content in India, and then whenever you hit that, it is diverted to that CDN location. That CDN location is connected to a location which is again a POP location somewhere in US. And when this communication between one POP to another POP happens, it happens on the Azure internal network. And that's why you are going to get a very, very fast response. Once the content is cached in locally in India, the next user who's trying to access the same content, he will have a very, very low latency because the data is already contained. So you can dynamically accelerate, you can remove it, you can cache it, whatever the content which is there on your the edge locations. So it is also possible to do that. What are the benefit? Very obvious. It improves the performance, it improves the experience, it gives a better experience for the end user. Thereby they will, they'll be able to use your application in a better way. Yeah, by using this, you are actually reducing the multiple round trips which is needed for your content to be cached or to download it to your large scale. It supports large scaling to better handle the instantaneous increase in the workload for your particular application. Distribution of user request and serving of content directly from the edge server so that less traffic is sent to the origin server. Whenever you use this the CDN, you have a concept of an origin server. What is this origin server? This origin server is nothing but the actual server where your content is. And then when you are using a CDN, it creates something called as distribution. And that distribution is going to be front ending your origin server. So whenever the content is not there with your distribution, the edge location, it goes to your origin server, pulls the data and bring it to the edge location. So this is how the CDN will work. Okay, so yeah, the same thing, just whatever I have just explained you, it is mentioned in this URL. Okay, so any additional user that can request the same file by using the same URL, then they will be routed to the POP and they will be able to get the content from there rather than going to the original server. Now within the Azure, the CDN service is supported by 4 products. Okay, so one is Azure CDN from Microsoft. So this is one of the CDN network. Then it uses Akamai CDN network. There's a company called Akamai, which is the leading CDN content provider in the world. It uses Akamai for the CDN. Then it also uses Verizon, which is also providing the CDN facility. There are 2 flavors. One is standard, one is premium. So let me just look at one of the URL and share it with you. Here it is. And find, yes. Okay. So here is the URL wherein you can see how the CDN works, how do you configure and so on. Another one is just an introduction to the CDN. And here it is. You will see how it works, when to use CDN, all those things are mentioned here. Okay, let's delivers the network. Yeah, this is what I have already explained, the origin server and all those things. Then, yeah, fine. Let's go next. Yeah, then we are going and now looking at the Azure SQL service. So yeah, so I have already explained you what is a SQL, yeah, structured query language. And when you want to configure a database, there are 2 types of databases, basically relational and non-relational. We have already seen that, so I'm not going to go into the details of it. What I'm going to go and show you is what are the offerings we have from your Microsoft. Hmm? So we will look at Azure SQL. Okay, this is the offering from your Azure, which is a family of managed, highly available, secure SQL server engines on the Azure cloud. Hmm? So you are going to get the functionality of a relational database by using the Azure SQL service within the Azure environment. Now, if you look at the offerings which are there with the what you can say Azure or in general the databases, it is going to look like this. So this is a graph which is talking about on the x-axis you talk about the efforts, the administration. On the y you are talking about uh, the cost. So if you look at any server offerings or any database offerings, if you are looking for what you can say on-premise, okay, on-premise offering, then you are going to have to pay for higher uh, cost, dedicated cost, as well as you have to do a lot of heavy lifting of your database. You have to manage it. You have to do administration of it. You have to bring a physical machine, install the SQL server, and work with it. Okay. If you move slightly up, and this is I would say the graph is like this in terms of lowering the administration and lowering the cost. And if you go up, you will move towards a kind of a virtualized or a cloud environment. So if you look at a slightly better version of this, instead of the physical server, you go for the virtual server, your efforts are going to be reduced, slightly reduced, and then even the cost. In this case, what will happen is you will have some kind of a server offering from your maybe your cloud private cloud provider, or maybe you are using a virtualized environment within on-premise and then installing the application on it. So in this case, what is happening is some of the efforts of managing, maintaining the physical server, patching the physical server, and all those things are reduced, and that might be taken care by your cloud provider, which is the private cloud provider, or maybe a virtualized environment. Then we move to a architecture where we have a offering as IaaS offering of your SQL server. So what will happen is a service provider or a cloud provider will give you infrastructure, and what you have to do, you have to install the OS, you have to you have to install the database and so on. So in this case, yes, some of your effort are reduced, but yes, you still have some amount of effort to be put in, and that's the reason it is showing that yes, your cost is actually getting lower because you are using a OPEX model rather than a CAPEX model, and also your what you can say your efforts are also reducing. Let me just take another color so that I can distinguish it. So once I am here, my administration is also getting reduced at this point. Then once you move to the platform as a service, okay, which is your Azure SQL database, yeah, Azure managed service. In this case, everything is taken care by your Azure. You don't have to worry about the underlying hardware, the patching of the hardware, the patching of the virtual machine, nothing. You have to focus only on your database administration. You have to take care of the database and so on. So that is being offered as a platform as a service. You don't have to worry about anything. That's it. As you go up, you can see there is very low administration and very low cost. So that's the offering of the service comparison of your SQL servers. So in Azure cloud, you have multiple offerings like this. Okay, so here it is. Sorry. Okay. Yes. Okay, so you have Azure SQL database, which supports your any cloud-based application on an intelligent managed database service that includes any serverless compute. So you don't have to worry about the sizing of the servers. It is taken care by your Azure. Then we have another offering, which is called as managed instance. Here, what you will do, you modernize your existing SQL application at scale with a fully managed instance as a service with almost 100% feature parity with the SQL Server database engine you have on your on-premise. This is a good option when you are looking for a migration of your databases from on-premise to the cloud. In this, you're offloading some of the work to the service provider. And the third one, which is nothing but the SQL Server on Azure VM, which is kind of a good case for a lift and shift model, which will lift your you will move your SQL Server workload with ease and maintain 100% server compatibility and as well as operating system level access. Yes, we'll see that in the details. Okay, so this offering, which is SQL Server database, it's a relation database as a service offering, which is hosted in Azure and which 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 works on a PaaS kind of a model. Which works as a PaaS kind of model. It is used for modern application, cloud application, wherein you want to use the latest stable SQL Server features and have the time constraint in development and marketing. So if you want to offload those things, this is the right choice for you. And this is fully managed SQL database server engine, which is based upon the latest version of your enterprise edition SQL server. So within your SQL servers, you have various editions, enterprise edition, standard, web edition, and so on. The SQL database has two deployment options built on the standardized hardware and software that is owned, hosted, and maintained by your Microsoft. Okay, so there are two options. The options are a single database, which will have its own resources and which will be part of a single SQL server. This option is highly optimized for modern application development on any cloud native or born in the cloud application. This option is available with your all cloud provider, which is also called as hyperscale, or it is also available with a serverless option. In the serverless option, you do not have to worry about any underlying hardware or the servers for it. Second option is a elastic pool, wherein you share the resources, the set of resources, by logically partitioning your SQL server. A single database can be moved of out or into this elastic pool as and when you need it. This is highly optimized application which will serve your what you can say SaaS based application pattern, wherein you use multiple tenants to host your application. So this is the SQL server for you. Two options, single database and an elastic pool option. Then we look at the manage SQL instance. Okay, and this falls under the PaaS category, which is best suited for migration from your on-premise to the cloud. It is nothing but a collection of a system and user database with a shared set of resources that is ideally suited for a lift and shift model. Now, what is lift and shift model? Move whatever you have on-premise directly to the cloud without doing any changes. It is best for application which are existing on your on-premise, and then you want to migrate it to the latest SQL. Okay, they are migrated to the cloud without any kind of a heavy lifting, or you can say minimal changes. An instance of SQL managed instance is similar to an instance of the Microsoft SQL Server database, which is installed on a shared resource and which has some additional features associated with it. Okay, so SQL managed instance supports database migration from on-premise with minimal or no database changes on the cloud. This option provides all PaaS benefits of your SQL server. Okay, this includes native virtual network supports and near 100% compatibility with your on-premise server. Instance of your SQL server provides full server access and feature compatibility for migrating SQL server to the Azure. So it provides you complete access to the underlying server. Yeah. And then the last one, wherein you have to do a lot of heavy lifting, you have to just spin up a virtual machine. Yeah, in your environment, and on top of that virtual machine, you go and installed SQL Server. Again, this is needed when you want actual OS level access to your SQL Server. Okay, this is a requirement for some of the customers where they say that yes, no, I want complete access to the OS of my whatever the database I am going to use it. With this method, okay, you have a very less lift and shift. What you can say, you don't have to do any kind of heavy lifting. Okay, it is good for a rapid deployment test scenarios where you do not want to buy any kind of on-premise servers, yeah, and that will reduce your cost actually. And then you simply go and use a virtual machine on the cloud, install the XVR server, and start running with it. Okay, the most significant difference from a SQL database and SQL managed instance is that SQL server on virtual machine allows full control over the database engine. Okay, so you can choose when to start the maintenance, when to do the patching, and so on, which is not there with the other offerings. So fine, this is what I want to cover for our SQL Server. Hmm? Any doubts in this SQL Server? Yes, no? Okay, thank you, Naved. Then we'll move to another database offering, which is called as Azure Cosmos DB. Now, this Azure Cosmos DB is a non-relational database, which is a fully managed NoSQL database, which supports your modern application. Now, this is if you attended the class for AWS, this is comparable to your DynamoDB. So it provides you a single-digit millisecond response time and automatic and instant scalability, which will help you to provide a super fast database at any scale. So it is very fast, and it is going to provide you a single-digit millisecond latency. So let me go and paste a link for you for this. I have given a link for the SQL. No, I have not given. Let me give it so that you can use it. So this is one of the link for the SQL introduction. Yes, here it is. So it will give you what is SQL, how you can deploy, what are the purchasing model. This is very important actually. Yeah, purchasing model. It operates on something called as core-based operating model and a DTU, which is nothing but the database transaction. Then DTO model is not available with your SQL. It is always recommended to go with a core-based model, which will the number of cores you have, your pricing is going to be based upon that. In the core-based model, you pay for your compute resources, any kind of a data and storage, and the backup. In based upon your whatever the SQL server you have, there is also something called as service tier, which will provide you right amount of performance and availability. Three types of service tiers available: general purpose, business critical, and hyperscale. Based upon that, you are going to get various features. So with hyperscale, you can get a highly scalable, which comes server as a free in Azure. So you have to go for the manage the yeah. So that will come free of cost for you. Yeah. Yes. So we can check that as well. So if you look at our free tier offering, Azure, Azure. Remember the first day when I asked you to create a free tier. Yeah, and in that here is yes. What comes in the free tier? You can see here. Okay, the Cosmos DB comes with 100,000 requests, and then your SQL database. This comes in the free tier. Okay, where is that? Okay, what happened? Yeah, okay, it came here, and here is your database. Where is your, yeah, here it is. Okay, like this, and it is going to give you a 250 GB of uh, yeah, S0 instance with 10 DTUs, and it is free for 12-minute period. Yeah, fine. Then yes, one more link. There are various case studies as well. Did I share this link? Yes, it is there. There are various case studies also available for how do you use your SQL for which purpose and all those things. You can see that in the link here. Okay, and yes, okay. This is yeah, it is kind of a scenario based. How do you deploy a solution? How you derive a solution for your SQL database and all those things. There are design decisions which you can make based upon this. Mission critical applications. What are the scenarios? Okay, all those things are laid down here. Then third one is, yeah, this is another one which is the fundamental of SQL. If somebody wants to start working on the SQL database, this is the fundamental of your SQL. What is SQL? Okay, how do you deploy on those things? Yeah, so I think this is the covering the same link. Fine. So go to the Cosmos DB again. Yeah, I was looking at the link for the Cosmos. Yeah, missed that part. Here is the Cosmos DB. It means convert the network one place to another. Nave not convert the network. Okay, it's a content delivery network. It is trying to deliver the content closer to the end users. It is not converting on one network from one place to another. No, Navid, that is not the right assumptions. I gave you the example of a user who's sitting in India and server is in US. Okay, so you can relate to that. So it is not converting, it is just delivering the network closer to the user. Okay, and this is a Cosmos DB module, which you can just go through it. And yes, and how do you work with Cosmos DB? Here it is. Again, very, very simple to work with it. I strongly recommend you go through these links. It is very, very useful. You can do some exercise as well and work with it. Okay, fine. Coming back to our Cosmos DB. Yes. Yeah, so it is fully managed and it takes the database administration out of your hand because it is managed service. It does automatic patching, updates, and so on your database. Then it handles your capacity management with your very, very cost effective serverless and automatic scaling operation. It can scale up, down based upon whatever the application needs. You can very well use it. Yeah. Some of the benefits of your Cosmos DB is it guarantees a speed at any scale. It gains parallel SLA backed speed and throughput, which will provide you a very, very fast global access and instant elasticity for any kind of your database needs. It provides you simplified application development. It helps to build your faster open source API, use multiple SDK, and it uses a schemaless data because it is working on the NoSQL, and it can also help you to do any kind of a ETL, no ETL analytics or operational data. It is mission critical ready. It guarantees a business continuity of 99.999% availability and enterprise level security for your application. This is also features of your Cosmos DB. Fully managed, and it is also cost effective. It lowers your lowers your the operational head. It is completely serverless, and you can do automatic scaling based upon your application needs and so on. Use cases for this: any gaming application, yeah, any IoT application which want to handle millions of requests at a super low latency of single digit millisecond. Yes, then this is the right choice for your database. Um, With this, you can have multiple options to do a read write of your data at any scale in a real time, near real time response. With this Cosmos DB, you get a very high throughput, very low latency as well. Okay, so yeah, that's it. Cosmos DB. Then we'll move to another topic, which is called as site recovery. Azure site recovery. Now, what is this Azure site recovery? Let's go and look at that. Okay. Yes. So take a scenario. Okay. So you have your application which are situated across the particular region. Now, as a part of your business continuity. Okay. So what is business continuity? It is about what you can say running your business irrespective of whatever what you can say disaster or any kind of a problem which happens due to some technical problems, yeah, or maybe some other problems. Still your business should continue to work as expected. Yeah. So any organization who wants to go for any kind of a business continuity plan and a disaster recovery mechanism, okay, to keep their data, their workload, their servers, all those things in a safe manner, then you need to go and use a service which is called as Azure Site Recovery. Okay. What this Azure Site Recovery is going to do is it is going to help you to do a kind of a yeah, business continuity by keeping a copy of your data somewhere else. Yeah, in a some other region, it will keep a copy of your data running in somewhere else in a some other region. So how does it contribute? It helps to have a business continuity by keeping your business application, apps, workload running, yeah, during the outage period. So whenever there is an outage because of any issues, be it like natural calamity, any kind of a attack, any kind of a technical problem, yeah, any link failure, all those things can be mitigated by using a Azure Site Recovery. The site recovery, what it does, it replicates your workload running on your physical as well as your virtual machine from one side, which is your primary side, to a secondary location. Okay, so it does automatically. It gives you a SLA. Yeah, when an outage occurs at your primary site, you are going to be failed over to the secondary site automatically. And once that is done, your app's going to be available for you to access. Okay. Now there is also a fallback mechanism. Whenever there is whenever your primary is available for accessing the application, for providing the service, then you can fail back to the service as well. Okay, that is also possible. Second use case of your Azure Site Recovery is to take backups. Okay, Sheikh, I will take the question after this. Okay, so let me finish it, then we will see that. Okay, so whenever I want to take a backup of my data, okay, I want to take a backup and keep that data backup safely, and I want to have a asynchronous backup of that data, then also I can use your Azure Site Recovery. I can move this data automatically from one region to another region and then use that data to recover my services. That is also possible with your Azure Site Recovery. So let me go and open that in a portal. Here is my portal. Okay. Yes. Yes, Azure portal, and I will, if you want to look at, so what I can do is just type in a site recovery here, and you will see. Yes. Yeah. Okay. So whenever you want to set up it, you have to create something called as service recovery vault. Yeah. And how you do that? Just go here This is a very lengthy process, but yes, uh, this is how you create a area and then create a name of the vault and then do it. So let me just go. Okay, I don't want to do that. Okay, let me go to this link. I have a link for it. We'll go to that link and then look at more details about it. Yes. Yeah. Okay. So, this is about your site recovery and how it is done. Okay. So yeah, tutorial. Yes. One of the. Okay. So how do you set up? You have to do lot many things. Yeah. For setting it up, um, you need to first create a service recovery vault. Yeah. And then, okay, then you have to enable the site recovery. And then after that, you need to enable the replication so that the replication happens. Once, yeah, once you enable the replication, then you have to select the virtual machine which is need to be replicated. And then once that is done, it will show that whether, yeah, your replication is happening properly or not. And then once this is replication is done, then you are ready to test it out. Okay, so once you have your replication done, you can also do a disaster recovery drill for your virtual machine to do a failure. So there is an option like this to do a test failure. The test failure, what happens is it can do a failure of your resources and see whether the resource is working properly or not. So everything is available in this link. I will share that link with you. So this is very, very powerful and very useful service. Here it is. Then how do you set up a replication? There's also option of replication. Yeah, this Azure Site Recovery is also used to prepare a migration from your on-premise to your Azure as well. Okay, that is also possible. Again, the same method. You have to create a service recovery vault, and then you have to uh, use you have to then prepare your on-premise virtual environment. For doing this, you need to use actually a agent, and that agent will help you to do a actually what you can say detailed analysis of your application, and then you can do that. Okay, you can take a snapshot. All those things can be possible. So yes, where is that? Automation. You can also set up the automation. Monitoring is also possible. You can do you can also monitor your recovery. This is the dashboard wherein you will see how many resources are backed, when was the last backup happened, all those things. You can also look at the view like this. It will show whether it is healthy, whether it's critical, that there is some error which has been detected, and so on. You can also do a failure test failure as well. So this is your recovery vault. Yes. Yeah. Your Azure Recovery Vault can manage replication for your VM, which is part of between the regions. It can also do for your on-premise. It can do for Azure Stack, and it can also do for your physical servers. Okay. Simply, what you have to do is to set up a recovery vault by replicating a Azure VM to a different region using the portal. You can minimize the recovery issues by sequencing the order of multi-tier application running on your multiple virtual machines. By doing this, it help you to ensure that there is a compliance whenever for your disaster recovery plan, that whenever it happens, it does not impact any of your work production load or your end user. As a way of automating, you can also use a traffic manager, which will, what it will do, it can use the traffic manager to route the traffic to your one region which is already always available. Once there is an issue, then you can divert the traffic to your disaster recovery site like this from here to here. In a sunny day, all the traffic will go to the region 1, but in a kind of a rainy day, or when there's a disaster which occurred in your environment, it can go to the this the second region. Hmm. So this is possible with your Azure site recovery. Yeah. Okay. Then we will move to another service which is called as Azure Migrate. Hmm? Azure Migrate. What is this migrate? This is a kind of I would say enhanced version. A centralized portal. If you want to look at that, let us go to the portal here and just type in migrate, Azure Migrate, and you can see it will help you to migrate your all data from the uh, is there any issue with my voice? Anybody? I will repeat that. Okay. But what I'm saying is your Azure Migrate is a kind of uh, a centralized hub where you can use various services to migrate your environment. Hmm. So let me go to the link for a Azure Migrate. Yeah, here it is. Hmm. Okay, thank you very much, Sheikh. Yeah. So I was saying it is a centralized hub wherein you can use this to migrate your applications from your on-premise to your Azure cloud. Hmm. So what can be how it can be done? Yeah, you can migrate your on-premise Hyper-V or VMware workload to your Azure infrastructure as a service. You can do a discovery of your application which is on-premise. Then you can assess your workload, and then based upon that you can do some kind of a check the dependencies and then migrate your workload. Okay, so I can just go here. What are the options? Hmm. You can look for any what you can say a virtualized environment which can be migrated to your Azure and so on. How does the migration process work? First, you look at the prerequisite, then set up a Azure Migrate, discover the virtual machine. You once you do a discovery, you will get a report. You review the assessment, and then based upon this assessment, create a project, replicate the virtual machine, and then test the migration, and then finally migrate into the production. So this is possible with all this thing. I will share a link for it. Here it is. Then more details on the discovery and assessment of your migrate is also available on this link. Yeah. How do you assess? How do you prepare? Yeah, all those things. You can go through this video. This is very, very good. Yeah, and this will help you. Like this, you can see a assessment tool which is available, which will assess all the details of your environment, and then it will give you a report of it, and then you can use it. Hmm. Then building assessment. Yes, you will see the number of servers which are available, all those things you can see. And then you can review your assessment as well, like this. How many of the machines are ready? Okay, some of them are ready with some conditions, some are not ready. What is the storage size? What is the cost? What is the cost of the compute? What is the cost of the storage? And based upon that, you can take a wise decision. This is possible with your migrate. Another link which is just focusing majorly on the virtual machine. Oh, here it is. Yeah. So I'm going to paste that in the chat as well. And this one as well. Okay, fine. Then come here. Yeah. So it provides you range of tools. Yes, it helps you to do server assessment, server migration, and so on. Okay. Once in the Azure Migrate Hub, you can look at uh, the assessment and then migrate. It can be on your on-premise server. It can be your any virtualized environment. It can also assess your on-premise database and then help you to migrate to the SQL database or even SQL managed instance. It can help you to assess your web application, okay, and then migrate to your Azure App Service directly to the App Service by using Azure App Service Migration Assistant. This is one of the tool which can be used. Then you can also migrate your VDI environment, which is available on premise. That can also be migrated to your Azure VDI environment. You can also use to migrate large amount of data onto Azure by using one service which is called as Azure Data Box. In this service, what happens is you actually use a physical box to send the data onto the Azure environment or Azure cloud. This box is shipped to your environment. You connect it to your network, get the data into it, and ship back to the Azure environment. Yeah. So this is kind of a pictorial view of whatever you can do. You can take any key migration scenarios. You can do a discovery assessment and then look at the migration capabilities. You can have a centralized repository of whatever the end-to-end tracking of your resources, servers, and all those things can also be done. So this is your Azure Migrate. And then we will move to the last topic of our Azure environment or Azure topic, which is called as Azure or the Resource Manager. Azure Resource Manager. What it does, it helps you to do a automated provisioning of your resources. Yeah. And this template, what you do, you define the resources you need to deploy to your Azure environment. So ARM templates are nothing but a declarative way to define the object you want to install. The type, the name, the properties are all done in a JSON file, which can be checked in using your source control tool and then managed the infrastructure just like any application code. So this is nothing but a Azure's native tool to provision infrastructure by writing a code. So if you need a way of developing your infrastructure as a code to the Azure, then the Azure ARM template is the way to do that. Okay, so if you have noticed it, if I show you, whenever we create a resource, whenever we create a resource like this, can you see here a JSON view here? Yeah, this JSON view is nothing but kind of a ARM template for your resource. You can see whatever you have created, it is showing a name, a ID, a type of that particular resource, then what is the front end, okay, name of the front end, all those things are shown here. Okay, so you can use this. Can you see here template? I can simply export this template, so it will generate a template like this. Yeah, and then I can just deploy this template to create another resource. So I can just visualize this template as well like this. Yeah, so you can see okay, if I just, so it is actually not that good, but yeah, you can just visualize whatever you are doing actually. So here you can see Yes. Let's go here. Okay, no, it is not giving a good view, but yes, you can see all those things, whatever the two resources which we are getting created, it is showing all this, and then you can use this ARM template to deploy a resource. Okay. And then you can look at the preview of the task. We have not automated anything. This is for the load balancer. Let me go to the EC2 machine as well. This is your EC2 machine. And if you go down, here is your template. Yeah. And it is generating a template. If I just visualize it, you will see a virtual machine now. Yeah, like this. Okay, but it is not actually giving a more detailed view of it, but yes. And here is the resources. What is the value, the type, what I have selected. Yeah, all those things you can visualize, and you can use this to create another resource with the same. So this, whatever the code, it is just a code of your actually virtual machine. And this is called as ARM template, like this. Okay, if I go here and type ARM as your resource manager, resource, yeah, manager. Where is the resource manager? ARM. It is not showing here. Okay, yeah. Just a minute. Yes. I can do this via parameter. Okay. So you can see here. Yeah, you can look at. Yeah. Quick start is also open. Yeah, here it is. The one which I've just shown you. Create resource. Then whatever the storage account you want to do. So this is actually the reverse of what I've shown you. Here you can see the template is created. Use this template to deploy. Just go to the deploy and just deploy using a template. That's what you can do. So here in this case, I can just do a deploy. Yeah, and I can just do a deploy like this, and it can help me to deploy that particular resource. Okay, here is one template, all those things, whatever I want to do, I can just do I can edit the parameter here. If I want to give a different name of the virtual machine, ability set, or anything, whatever I want to change it, I can change it from here. Discard, so on. Yeah, you can look at the disk. I can do a edit template as well. I can change the virtual machine type here and so on. Like this, you can do that. So that is the ARM template for you. Just a minute. Let us go to the. Yeah. So how does the ARM template look like? Yeah, how it has something called a schema, and this schema is mandatory, and it must have the location of the schema file. Like this in our template, we can see a schema file here. Yes, you can see here there's a schema file, and which is this one. Then you have, yeah, this is the schema. Then you have the content version. Yeah, it is also mandatory. It is just the version number to be used to track the version of the template. And then the parameter are nothing but the values you need to enter before the deployment can start. You can customize these parameters, for example, the username, like this, the password, the domain name, and so on. And then the variable for, yeah, you can also put in this virtual machine size and so on. And then the variable, what is the variable? They will just simply help you, yeah, to kind of have a what you can say, a dynamic way of defining the variables. And then the resources. This is the most important part, wherein you have to define the resources which you are going to create. For example, you can see here it is trying to create a resource type as a storage account. You can see all the resources will start with like something Microsoft dot storage dot compute dot network and so on, and then followed by the name of that storage account, yeah, or the public IP address or the VNet and so on. Then API version, this will be the API version and the location and the name, and the kind will be storage for your, or you can see, or some kind as compute and so on. So your resource will be a kind of a collection of resources or the compute storage or this, which will be deployed as part of your deployment template. And then the last one is the output section. What is the output? The output is used to return a data or object from your deployment. For example, if I want to output, okay, here I did not specify. Yeah, wait a minute. If I say output of this as a public IP address, now this output can be given for you as a user to use as a IP address to open the web server for your whatever the virtual machine you are using. So this is nothing but the value which is passed to the end user, which he can use to get access to that particular resource. So this is your complete definition of your ARM template, various sections which are part of your ARM template, parameter, which is variable, then version, and the resource, which is okay, a mandatory section. Okay. So if you need to know more about ARM template provisioning, here is the link for you. Yeah, here it is. Yes, ARM template. Go through it. Here it is. Yeah, complete what you can say, complete tutorial for you to just deploy a resources using the ARM template. Syntax, parameters, all those things are there. Okay, so that's it. We have come to the end of our Azure section. From tomorrow, we are going to look at GCP. Okay, so for GCP, we will start from tomorrow. Yeah, and so for your GCP free tier, you need to create a free trial account. Here is the so you can have a certain workload which are free of cost. Yeah, and then you also get a credit of 300. So we will look at Sheikh. We will look at the basic things like compute, yeah, storage, networking part, and so on. So you can access, Naved, you can access your ARM template like this, what we have just seen. Here it is. You can see the JSON view of the template, or you can create a template by going into this resource and then export template. In the export template, it is going to create a template for you, and you can download this template like this, or you can add to library, or you can simply use this to deploy the resources. Okay, Naved? Yeah. So all of you go and create a free tier account for your GCP, and we are going to use it tomorrow. And it will give you some compute engine. It is called compute engine, which is nothing but a virtual machine, and then the cloud storage, which is your storage on the GCP. Okay, and then the data warehousing solution, or the NoSQL, which is called as Firestore. All those things which will come free of cost for you. And you will also get $300 credit. Okay, this is for the new customer. So create this and we will see you tomorrow. Okay, now for the GCP, we will keep it very, very, I would say, what you can say, very high level. Okay, and will not go deep dive as we have gone with the two service provider, but you will be able to relate all the services which are there. And then what I'm going to do is I'm going to have a session which will cover a kind of a comparison between all the services of Azure, GCP, and your AWS. That will give you a clear understanding of what the services are and which service to be used for what. So I'm ready to take questions. I could see some questions before. I will just go through it. Just a minute. Yeah, somebody asked me. Okay, somebody asked me what is app service and why it is used. Okay, so app service, Sheikh, app service we have already seen in earlier classes. It is a PaaS offering wherein you just have to bring your application code, host it on the Azure app service plans, and start using it. Whatever the underlying services, whatever the underlying servers or hardware which is needed, it is taken care by your app service plan. All you have to do is to bring your code and that's it. Host it, and you will be able to run your application. Okay, anybody else? Again, whatever the data which you have, yeah. So can we store photos and videos in NoSQL database like DynamoDB and Cosmos DB? Okay, so go and look for it, search for it. Okay, so whatever the content you are going to store it in kind of a, I would say, a value. Yeah, it is not going to be visible as if it is a photo for you. Okay, but it is kind of a data which will be visible. But yes, if you need to do that, yes, there are various ways to do that. You can just go and look for an option on the internet. Okay, so I have never tried to store a photo as a what you can say object in your what you can say in a NoSQL database. Okay, like we store file location in SQL. Okay, so if you are talking about the file location, then that's a simple thing. Yeah, but if you are asking that to store a complete file as a object, that is something different. How do I use Azure DevOps to ARM template? Okay, so you can automate this infrastructure as a code. You can automate it and you can call it that ARM template in your Azure DevOps pipeline. That is completely a big topic, Naved. If you need more details, I can give you a link for your Azure DevOps and which can help you to do automation. Okay, so if you go for Azure DevOps, yeah, and yes, if you look at Azure DevOps, yeah, here is the DevOps services. In DevOps, you will have many services like, for example, Azure Pipeline, Azure Repos, Artifact, yeah, and then Azure Board. So you have to just go and look at all these options. Okay, you can create a pipeline. In the pipeline, you can call your actually ARM template and then use it to create the resources. So there are so many things you can do in the DevOps. And if you ask my personal opinion, Azure DevOps is far better than the AWS DevOps. Yeah, this is my personal opinion. Okay, just don't go with my personal, just go evaluate and then look at for it. So you can look at for various things here. If you go to the documentation, you will get more details. How do you get started with DevOps? How do you create a project? All those things, it is available in this. Here is the link I will give you. But yeah, it is a very big topic, Navid. Anybody else? Any questions? Anybody else? If you don't have any questions, we will end it and we'll meet tomorrow. Yeah. Okay. So we will meet tomorrow. Yeah. Thank you very much and see you tomorrow then. Okay. Bye. Thanks. Thank you. Thank you, all of you. Bhumika, I'm not sure about it. You may check with Bharat or your contact in ExcelR to get the details about it. Okay. Yeah, it is better if you can download it and use it.
Video is available for lifetime. You can access anytime.
Very good. Thank you, Amar. Thank you. So bye.